Deal with half angles. Once again, it's a matter of application of formulas. On page 138, 139, you will only be dealing with applications of the half formulas. You won't be dealing with any identities with it. I don't even think I'll have any trig equations for you. So with those, so problems 13 through, 15 to 24, you had 15 to 24 to do. I have a trig equation there. Once again, if you're dealing with a trig equation, you just take it from right back to left. You just take it from right back to left, and you work your trig equation. So problem number 24, I have 1 minus cosine of theta over sine of theta. Well, that's equal to the tangent of half theta. So you have tangent of half theta is equal to square root of 3 over 3. Take the inverse tangent and solve your problem as you normally would solve the problem. Once again, you should be a little bit more comfortable and familiar with the types of problems because we've done these problems already. You've seen them, you've done them. It's just applying a different formula with them. So hopefully you feel a lot less anxiety than you did a week and a half ago when we were going through these. I'm still not saying it's perfect by any means, but hopefully your anxiety is a lot less because it is applying the same types of situation to problems each and every time. Is there anything that you would like me to go through? Yeah. Number 24. We have 1 minus cosine theta over sine theta is equal to the square root of 3 over 3. So you look at the left-hand side of that equation, all the equations that we did yesterday. Your left-hand side. Or if I gave you a formula sheet, you pull that out. And you work with that formula sheet. Okay? And I would look at the half angle ones. Okay? Your half angle ones. Which one looks like 1 minus cosine theta over sine theta or A? And that's what? Which one is it? Tangent. So we have tangent half theta is equal to square root of 3 over 3. And you can write it half theta that way, or you can write it theta over 2. That is fine. We have to get rid of tangent. We're solving for theta, general solutions. We have to get rid of tangent. So Phil, what do we do to both sides to get rid of tangent? Inverse tangent. So we take the inverse tangent now. That will cancel this out, so we have theta divided by 2. Now, what you have to really watch out for in your calculator, doing the inverse tangent, when you throw in the square root, some of your calculators will throw a parenthesis in there. You need to close the parenthesis out. Other calculators, you have to hit your right button to pull yourself out of the radical. Okay? Now we're taking the inverse tangent. You're going to have to take a parenthesis and put it in front of that too, my bad. And that's usually given to you already. The inverse tangent. They'll throw a parenthesis there. Use your right arrow or pull yourself out of the radical, and we divide by 3 and we close that parenthesis out. Once again, some of the TI calculators are a lot different now, but you have to use that right arrow. Let's see here. So we have, we have inverse tangent. I have inverse tangent. Throw me the parenthesis already. I have square root of 3. Oops. Bless you. Square root of 3, close the parenthesis out. I divide that by 3, and I need to make sure I close my parenthesis out there. Should get 30 degrees. So we have theta over 2 is equal to 30 degrees. If I have theta divided by 2, how do I get rid of that division by 2? Multiply both sides by 2. So we have theta is equal to 60 plus or minus the period n. Well, our b value here, I have half theta or theta divided by 2. My b value, once again for tangent, or the period, is 180 divided by the half, or 0.5. So we have 360 n. Another way of thinking about this, okay, when you do your inverse tangent, think of it this way. I do my inverse tangent on both sides. My theta over 2 is equal to 30 plus or minus the basic 100 or 180 degrees for the period for the tangent. And then when I multiply through by 2, I multiply everything by 2. So I have 60 plus or minus 360 n. That's another way of thinking about it. Other questions? Once again, it's the same type of problem, except for now I'm applying a half angle problem or half angle formula to it. Solve my equation. All right, today is a happy day because this is the last day of new material for the trig identities. Last day. But along with this, we have 8 formulas that get thrown onto this. Blah, blah, blah. We get 8 formulas. If you have one of my trig identity sheets, it's the bottom 8 ones that the bottom 8 ones on the sheet. Once again, I said we will deal with 2 trig identities on this final test on trig identities. The first one will be a double angle one. The second one will be proving one of these ideas here. These are called sums to products formulas. Okay? You have sums and you have products. When you have sums, we are adding. When we have products, we are multiplying. If we take a look at the left-hand side, we have the sine of a plus b plus the sine of a minus b. Okay, we have a bunch of addition things going on over here. On the right-hand side, we have multiplications, which means we have products on the right-hand side. One of your trig identities is going to be proving one of these top 4. Well, how do I prove one of these top 4? Well, what we were asking is write out here, what I'm asking you to write out, is I want you to write out the sine of a plus b plus the sine of a minus b. So I want you to expand out the sine of a plus b and the sine of a minus b, which you already have on your identity sheet. So you look at your identity sheet, sine of a plus b, write it out. What's the sine of a plus b? Plus the sine of a minus b. What's the sine of a minus b? So you're just writing these out. First one, sine of A plus B is sine A cosine B plus the cosine of A times the sine of B. The second one is exactly the same thing, except for you have subtraction in there. Sine A cosine B minus cosine of A times the sine of B. Okay, all we've done is used our angle addition formulas and expanded out. Now, if we take a look at our two terms here, I have sine A cosine B, I have cosine A sine B, I have sine A cosine B minus cosine A sine B. Can I combine, can I cancel any two terms? I take a look at what I have here. I have sine A cosine B, I have sine A cosine B. I have cosine A sine B, then I have a minus cosine A sine B. What happens to the cosine A sine B's? They cancel out. Because one here, this one is a positive cosine A sine B. This one here is a negative cosine A sine B. They're identical terms, one plus, one minus. So they cancel out. That'd be like going, let's see, if I had xy plus yz plus another xy minus yz, change this back into the algebraic world. And you're over in Dr. Reed's class and you're asked to simplify xy plus yz plus xy minus yz. Both those yz's cancel out. This yz and this yz go bye-bye. But I have an xy plus an xy. If I add an xy plus another xy today, what do you come up with? 2xy. You come up with 2xy. Well, if I have a cosine A cosine B plus another sine A cosine B, that gives us what then, Grant? 2 sine A cosine B. Which is what we're looking at. We is done. We did. Yeah.
Why would it be 2 sine A 2 cosine?
If I have one xy here and I have another xy here, how many xy's do you have? If you have one xy here and you have another xy over there, how many xy's do you have?
2 xy.
2 xy's.
So, oh yeah, I see.
All right. What you will be asked to do, you'll be asked one of these first four. I'm going to say prove it. And how you prove them is you're going to have to expand out using your angle addition formulas, expand them out. 2 terms will cancel, 2 terms will combine. You're done. Your angle addition formulas are already here on your sheets that you have to just expand them out. Like I said, 2 terms will cancel, 2 terms will combine. Now, if I take a look at what I have here, I have 8 formulas on here. On the right-hand side of all these formulas, on the right-hand side of all these formulas, what we have is we have multiplication. This is all multiplication here. So on the right-hand side, we have all your products. because we have all multiplication. On the left-hand side, what we have is we have all addition and subtraction. Sine of x plus sine of y. Sine of x minus sine of y. Cosine x plus cosine y. Cosine x minus cosine y. So what we have on the right-hand side are all sums, and we have some differences also. We have sums and differences. So on the left-hand side of your equal sign, you have all your additions and subtractions. On the right-hand side, you have all your multiplications. These 8 equations, or these 8 formulas, should be added to your formula list that you have compiled. This is the last of all of these. I'll give you about 5 minutes if you would like to add them. As we will refer to them here in a few minutes. So if we go back to our algebra days, and I ask you to solve the equation x minus 3 is equal to 0, what would you do to solve that equation? Yeah, x minus 3 is equal to 0. Or would you?
Add 3.
Yeah, you'd add 3. We add 3 here, we add 3 here. This would give us x is equal to the value of 3. But what if I added x squared plus 2x minus 3 is equal to 0, and ask you to solve that? We no longer can just subtract our 3 or add our 3 over and say we could solve this. What do we have to do to solve this now?
Is this the one where you like put in the parentheses and expand it?
Expand it out, you put it in parentheses. You factor it down. So we have two factors. These two factors would be x plus 3 and x minus 1. Factoring it down. And then what do we do with each one of those factors? Set them equal to 0. So x plus 3 could equal 0. X minus 1 could equal 0. So the x would equal negative 3. X would equal 1. We had to factor it down. And we had to get each factor equal to 0. We couldn't just solve by adding 3 and then dividing by 2 up there like we did over here. What we are using here is the multiplication property of 0. The multiplication property of 0 says if you have things that are multiplied together to equal 0, one of those things must equal 0. But what you have to get into is you have to get into multiplication. If it's not a multiplication, you can't solve it. Well, if I have the sine of 5 theta minus the sine of 3 theta, well, the first thing you sit there and say, well, bless you, isn't that just the sine of 2 theta? Oh, that would be so nice. But unfortunately, no, it's not. Just like when I had sine of A plus B, I couldn't say that's the sine of A plus the sine of B. I couldn't just distribute it out. I can't combine the like terms like I did in algebra. But what we can do is utilize ideas that we just talked about. Because what we have here is we have the subtraction of 2 sines. I have a subtraction of 5 theta, subtraction of 3 theta. We have an A and a B, or an X and a Y. I have two different things there. 5 theta is not the same as 3 theta. 5 theta is not the same as 3 theta. If you say it is, the same thing. Okay, we'll take $5. You give me 5 times that $5. I'll give you 3 times that $5, and we'll call it even. Doesn't work that way. But what we can do is take a look. The 8 formulas that we just had. We have sums and differences, which means we're looking at the left-hand side. Do we have somewhere along the bottom, or at the bottom of those last ones you did, do we have one that says the sine of one thing minus the sine of a second thing? Yeah. It's the second one down. Sine of A minus B is equal to 2 sine. Or we use X and Y. Sine of X minus sine of Y, two different things, is equal to 2 times the cosine of X plus Y times the cosine, or times the sine of X minus Y. So what we can do, this is my X and this is my Y. I can rewrite this as 2 times the cosine of X plus Y. So we have 5 theta plus 3 theta divided by 2 times the sine of 5 theta minus 3 theta divided by 2. All we've done is we've replaced the X with 5 theta and the Y with 3 theta. But the most important thing, what we have just done, is we've taken it out of addition, subtraction, and moved it into multiplication. Now we're multiplying a bunch of things together. Well, I got addition in there, Mr. Gregory? Yeah, we do. But can we find, what is 5 theta plus 3 theta? 8 theta. Divide that by 2? 4 theta. So this is 2 times the cosine of 4 theta times the sine of 5 theta minus 3 theta. 2 theta divided by 2. So we have the sine of theta. This is equal to 0. What it allowed us to do? It allowed us, once again, to move to addition, subtraction, into multiplication. Using our multiplication property of 0. One of these factors must equal 0. If I have things being multiplied together to equal 0, one of those things must equal 0. Just like up here, we set each factor equal to 0 and we solve. We set each factor equal to 0 and solve. We have cosine theta, cosine 4 theta is equal to 0. I want to solve for theta. I have cosine there. How do I get rid of cosine? Inverse cosine. Hey, we're learning something here. So we have 4 theta is equal to inverse cosine of 0. So clickety-clack, clickety-clack. Inverse cosine. Oh, by the way, this thing it's like a cat. This calculator, it's like a cat. Cats have 9 lives. Cats, this thing grew legs, ran away sometimes. And then out of nowhere, when you think the cat is done, gone, bye-bye, adios, it's roadkill out there, it's a sail cat. Okay, it's a sail cat. You know what a sail cat is? Sail cat is a flattened cat on the road, and you can pick it up by the tail, and you can... It's called a sail cat. Doc White, my old chemistry teacher, coined that phrase to me. That's a sail cat. You can pick it up by its tail and throw it like a frisbee. I don't know, okay. But that's what, when you think it's gone. When you think it's gone, sorry if you just lost a cat. My bad. I don't mean to offend anybody. Sorry.
Someone's cat died?
No, but if it did, I'm sorry.
Oh.
I didn't mean to offend anybody. Just when you think it's gone for good, this morning, it's magically here. It's like the cat you just showed back up at your door that was gone for a month. It's now back. It's a boomerang. It's a boomerang calculator. Boomerangs go out and they just keep coming back. It's a boomerang. I was amazed. I looked there and it's like, wow, it's back. Anyways, inverse cosine of 0 is what? 90. But when we take the inverse cosine, we have the principal value. And also it's what? Opposite, negative 90. That's what we're learning here. Dividing by 4, dividing by 4, dividing by 4, dividing by 4. 45, 22.5. So we have theta is equal to 22.5 plus or minus the period end. Our b value is turned into 4, so the period is going to be 90 degrees. And we have a negative 22.5 plus or minus 90 n. Then we go to our second one. Inverse sine of 0. Inverse sine of 0. 0. Plus or minus. And then also it's supplement. What's the supplement to 0? What do we add to 0 to get to 180? 180. Plus or minus Our B value is a value of 1, so we have 360n. 360n. So we have 4 general solutions here. This is problem 27. Very similar to problem 27 that you'll do for the day. Rewrite as the sum or differences of sine and cosine of positive angles. These are problems that you will see that are problems 3 through 12. What we have is we have products. We want to write them as sums and differences. So products are on the right-hand side. I'm looking for one that looks like 2 sine of an angle times the cosine of another angle on the right-hand side. 2 sine of something times the cosine of something. First one. The very first one we did. Very first one we did. 2 times the sine of something times the cosine of a different thing. So here's your A, here's your B. So we sub it in. We're taking it from the right. What's it look like on the left? Sine of A plus B. Minus or plus the sine of A minus B. So A is 40, B is 60. So I just sub in your 40s and 60s. So we have sine of 100 plus the sine of negative 20. Problem is I ask you for positive angles. And I have a sine of a negative 20. So this goes back to what we talked about last section, the odd and even functions. When I have the cosine of negative x, this is equal to the cosine of x. Cosine of x and negative x are the same. They are even functions. If I put in 30, I put in negative 30. I take the cosine of an angle. It's going to give me the same value. When I'm dealing with the sine, though, sine is an odd function. The sine is an odd function, so if I substitute opposites in, I get opposites. So when I have a sine, I can just bring my negative sign out front. So we have negative sine of 20 degrees. For the sine, the negative will just come out front. Problems 15 and 24 are going to look like this. Rewrite as the sum of products of sine and cosines of positive angles. Or rewrite the sum as a product. So we're starting with a sum, we're going to a product. So we're looking for one that looks like cosine plus cosine on the right-hand side. Cosine plus cosine. Second from the bottom. Second to the last one. Cosine x plus cosine y. Second from the bottom. Cosine x plus cosine y. So here's your x and here's your y. So we expand that out. We have 2 times the cosine of x plus y divided by 2 times the cosine of 30 minus 80 divided by 2. Now it becomes a clickety-clack exercise. Thirty times 80, 110, divided by 2, 55. 30 minus 80, negative 50, divided by 2. But once again, I want these at positive angles. Well, if I have the cosine of negative 25, this is an even function. What we were able to do with the cosine is get out our eraser postulate. And we can just drop our negative sign. So in problems 15 to 24, that's what you're doing here. Problems 3 through 12. 3 through 12, you have these types of problems. And problem 27 is one equation that you will have to solve. Tomorrow when we come in, there'll be a worksheet. The worksheet will be all the stuff put together. All the stuff, double angles, half angles. I don't know if I'll do an in-class assignment or not. I might, I don't know. I'm flipping a coin right now, my bad. But the worksheet will be everything put together, sort of like the review for the review. Monday of next week will be review day. Tuesday next week will be the last quiz on trig identity. Whoop, whoop. QED will be done. The rest of the time is yours.